So today we're going to begin section 2. Monday we'll finish it up. Today you're going to be introduced to logarithmic functions. Then on Monday we will graph them. So what we're going to be doing today is we're going to be switching between log form and exponential form. Now, probably back in middle school, you learned about inverse operations. And you learned that the inverse of addition was subtraction and the inverse of multiplication was division. Today, you're going to learn that the inverse of the log function is going to be the exponential function or equation. So right here, notice the arrow in between. This is given to you in log form, and this is exponential form. So what we're going to be doing is switching between the two forms. Now, several years ago, I taught regular algebra 2, and I was trying to come up with a cool trick because my students were kind of lost with these logs, because traditionally, logs are a bit challenging. So I was looking online trying to find some cool tricks to teach them to get the hang of switching between the two forms. And all the tricks I was seeing was like, oh, rotate the stuff counterclockwise or do it in a semicircle or all these different things. And I'm thinking, well, they're going to forget which way you have to rotate the things around. So then I started thinking, well, if these are inverse functions, and if you've ever heard the saying that opposites attract, think of the log and the exponential as being opposites. So the bay to the exponential is going to be the log function. So what we're going to do is we're going to be spelling out or using the letters of bay, and we're going to be putting them into the log. Because I thought to myself that everyone understood that when you have an exponential equation, I thought that everybody understood that the 2 is the base, the 3 is the exponent, and then the 8 is the answer to the problem. So when it's in an exponential form, it's going to spell the word b. But then to turn it into log form, we're going to spell bay. So we're going to take the word log, we're going to put the b here, it's like a little subscript. Then we're going to put the a, which is the answer, and then we're going to put equals the exponent. So then equals the e. So it's going to go from b to bay. And then this is how we switch it between the two forms. So for example, on my 2 to the third equals 8, to switch this to log form, I'm going to put the 2 down here as the base. I'm going to take the answer, which is going to be the 8. And I guess I can just do it all in black, equals 3. So the answer equals the exponent. So you're spelling the word bay. So these are inverse functions, and we would reverse it from one form to the other. What we're going to be doing is using this switch to solve either an exponential function or a log function. So if the given problem is given to you in log form and you don't have a calculator and you're expected to solve it, sometimes by transforming it into exponential, then you can solve it. So we're also going to see the graphs of the log functions on Monday. We already saw the exponential graphs. Remember, most of them went through this order pair of 0, 1. And the exponential look like this. The log, since it's inverse, is almost like, it's like a flip, or it's going to be symmetrical. So over here you would flip the x and the y, and the log graph is going to look like this. And it's going to be symmetrical across this line of y equals x. And we're going to see this on Monday. So just know that they are inverse operations between log and exponential. So the first 6 examples, this is all we're going to be doing, is practicing transforming it from a log to an exponent. So here, if it helps you to write in the letters B, A, E, when we go from log, it spells bay, but remember when we go to exponent, we're going to spell B. So let's fill it in. So the base of the log, this little 2 here, is always going to be the same base in the exponent. So it's going to be 2 to the 3rd power equals 8. When I go from log to exponential, this exponential equation that you write needs to make sense. If 2 to the 3rd power didn't equal 8, I did something wrong. So it's easier to check when you go from log to exponential. Now, when we go from log to exponential, the only way you could check it is if you had your calculator. Let's try the next one. So again, B, A, E, and now I'm going to spell B. So 1/2 raised to the -4 power equals 16. Now, let's see if this makes sense. Remember when we have a negative exponent, so 1/2 raised to the -4 power, this really means flip it to the reciprocal and then make the exponent positive, and then 2 to the 4th is 16. So the equation I wrote is correct. So that's your answer, what I boxed in yellow. Over here was just checking to see if it made sense. Number 3, again, it's in log form. When it's in log form, we're spelling bay. So now we're going to take the base, put the exponent, which is 5, and make it equal the answer, which is 100,000. 10 to the 5th power is 100,000. I did do it correctly. Now we're going to go the other way. I'm giving you the exponential form, and I want you to transform it to log. So again, this is the B, this is the exponent, this is the answer. Remember, when we put it in log, we're spelling bay. So let's go ahead and put in the numbers. Log base 5 of 25 equals 2. So it's just a matter of making sure that you put them in the right spots. This we could do on our calculator, but right now we're not using calculators. Let's try number 5. Again, I'm going to transform it. Remember, this is the base, this is my exponent, this is my answer. So log base 3 of 1/81 equals -4. So we're just rearranging. Let's try number 6. Coming up on the next slide, we're going to learn a property about the 0 power. Remember, anything to the 0 power equals 1. But let's go ahead and put this into log form. B, E, A. And now we're going to spell bay. Log 3/4, base 3/4 of 1 equals 0. Whenever you're finding the log of 1, so whatever the base is, if this is a 1, this answer will always be 0. Because in exponential form, anything to the 0 power equals 1. Now we're going to try the property. Let's do of them. So the first one is what we just did. So again, if I transform this property, BAE, and put it into exponential form, you're seeing this. A to the 0 power equals 1. And what this means is A could be any number. It could be 100, it could be 1,000,000. Anything to the 0 power equals 1. So remember, when you see it in log form, if this number is a 1, this answer over here is going to be 0. Doesn't matter what base A is. So this one's more or less common sense. The next one as well. Again, B, A, E, A to the first power equals A. So here, when this base is the same as the number that you're taking, it always equals 1. So let's try an example. Let's say we have log base 3 of 3. It's always going to equal 1. But let's go ahead and solve this like we did before. Let's turn this into exponential. So BAE. So 3 to the x power equals 3. Remember, when the base, you make the bases the same, you get rid of the base and you solve what remains. And x equals 1. So this next one is involving a power. So here again, we could do B. This whole thing is A, and this is E. So A to the x power equals A to the x. So let's go ahead and try it with some numbers. Let me come down here. Log base 3 of 3 to the 4th equals x. BAE. So if we do 3 to the x power equals 3 to the 4th. Notice the bases are the same. So x equals 4. So really what we were saying here is 3 to the 4th equals 3 to the 4th, because you would put the 4 up there. And that's what we had here. So that's all it's saying there. And then the last property is just saying that if you have exactly the same log base on both sides, this cancels, and then you're just left with x equals y. Again, I can try this with some numbers. Let's say you were given log base 3 x, log base 3 4. The log base 3's cancel, and you're left with x equals 4. So be familiar with the properties and how you can use them to simplify your problems. Let's try some examples now. So now we're going to apply the change from one form to the other, and then we're also going to use properties, and then we're also going to use the skills that we learned in 5.1, where once we put it in exponential, we're going to change the bases to make them the same, cancel them out, and solve what remains. So let's try our first example. So here we go. It's in logarithmic form. I'm going to turn it into exponential. This is the base, the answer, the exponent. We're spelling bay. So 2 to the x power equals 32. This was your 5.1 homework. We need to make the bases the same. So I'm going to change 32. So it's a base 2. And it's going to become 2 to the 5th. because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 one more time, and it's 32. Now that the bases are the same, get rid of the 2's, and x equals 5. For the next one, we'll do something similar. Again, it's spelling bay, so B-A-E here. So we're going to write 4 to the x power equals 2. Again, I'm going to use my change of base. I'm going to change the 4 to a base 2. I can now cancel the base 2's. Remember, this one has an assumed 1 exponent because 2 to the first is just 2. And now I'll multiply the power to the power, and I get 2x equals 1, divide by 2, and x equals 1/2. Because if you think about it, if you come back up here and you put the 1/2 here, okay, so if I were to plug it in, 4 to the 1/2 power, that really means find the square root of 4. So the square root of 4 is going to be 2. So you can plug it in to what you turned it into to see if it makes sense. Let's try number 9. BAE again. So 3 to the x power equals 1. Here's where we're using property number 1. You should realize that anything to the 0 power equals 1. So x has to be a 0. This is where we're just using our property. We can't change the bases here, but we can apply a property. Let's try number 10. So for number 10, what we're going to do here, again, BAE. So I have 10 to the x power equals 1/100. I'm going to change them so they're the same base. 10 to the x, 1/10 squared, which really becomes 10 to the negative 2. The base 10's cancel, and I'm left with x equals negative 2. Number 11, here comes that property again. BAE, so 6 to the x power equals 1. Again, anything to the 0 power is 1. So x equals 0. Now you may see questions where they may just say, find the value of this. And as soon as you see this, you should realize that it's going to be, your x is going to be a 0. And that's that property. Let's try number 12. Still in log form. BAE, so 5 to the x power equals 1/125. I need to make it the same base, so I can first do this, because 125 is equal to 5 to the third. And then now I can make this 5 to the negative 3. Now, if you realize that 1/125 is this, you could skip this step and go right to the negative 3 power. My bases are the same. Get rid of the 5's, and you're left with x equals negative 3. Let's try number 13. Again, BAE, it's in log form, so we're doing 7 to the x power equals 343. I need to figure out what that exponent is, so I'm going to change the base. I know that 7 to the third power equals 343, so I'll change that one to 7 to the third. I now have the same base, get rid of the 7s, and x equals 3. The next one, I'm going to turn it into exponential form. So x to the third power equals 8 over 27. Now, what's different about 14 is all the other ones, my variable was an exponent. Now my variable is a base. This is what we did at the beginning of the year. So in order to find out what x equals, I need to cube root both sides. Cube rooting this cube makes it cancel out. And then I can do the cube root of 8 over 27. Just recall that you could actually cube root 8 and then cube root 27 if that's easier for you to see. And then this becomes cube root of 8 is 2, cube root of 27 is 3. Remember, when you take a cube root, it's only whatever sign is there. So they were both positive, that's why it's positive 2/3. Remember, when you square root or do a fourth root, an even root, you have to put plus minus. Number 15. Again, I'm going to turn it into exponential form. 4 to the 5 over 2 power equals x. So here, I'm just figuring out what x equals, so I only need to simplify the 5 over 2. So remember, the 5 over 2 exponent, the 2 is the root, the 5 is the exponent. So I'm going to be doing the square root of 4 and then raising that answer to the 5th power. So the square root of 4 is plus and minus 2, and then I'll raise that to the 5th, and I get plus and minus 32. Now, what we're going to see on Monday is this number that's here, the number that you're trying to find the log of. This number can never be negative. So what we need to do is throw away the negative 32 answer. So here, the only answer that we're keeping is the positive 32. If you were to key this in your calculator, you would get an error. Let's try number 16. Same thing, it's still in log form, so I'm going to turn it into exponential. So 49 to the x power equals the cube root of 7. I'm going to apply my change of base. So I'm going to figure out that 49 is 7 squared. And I'm also going to change the cube root of 7 to 7 to the 1/3 power. I can get rid of the 7s. Remember, here you're going to multiply power to the power, and I get 2x equals 1/3. Now I need to solve for x. Now you can either say, well, I'm dividing both sides by 2. You could also think that I'm multiplying both sides by the reciprocal. However you want to think of doing this. Whenever I have fractions involved, I like to think, well, I'm dividing by 2, which is the same thing as multiplying by 1/2. So that cancels, and I'm left with x equals 1/6. You could have also added a 1 under the 2x and then solved this also as a proportion and gotten 6x equals 1, divide by 6, x equals 1/6. It doesn't matter, you're just trying to isolate x. Number 17, same thing. It's in log form, it spells bay, we're putting it into b. So 5 to the x power equals 1 over 625. I know that 5 to the 4th power is 625, so I can change this one into that. And then I need the same base, so I'm going to change it into 5 to the negative 4. I now have the same base, get rid of the 5s. So now I have x equals negative 4. $18, same thing. We're moving it from log to exponential. So base 10 raised to the x power equals 0.001. Now, I'm going to go ahead and change this to fraction form. However, if you realize that 0.001 is 10 to the negative 3, you can also go straight to there without making it fraction form. These are the same base, so answer is x equals negative 3. Soon as you see that you've got a decimal or a fraction there, that should be a clue that we're dealing with negative exponents. Yes? Yes. Pretty good? Let's try 19. Okay, so for 19, now we haven't seen it set up like this, but if they have x equals, you can always take this and move it over to this side. So now you can spell out your BAE. So let's go ahead and fill it in. 8 to the x power equals the 4th root of 8. I need to change this so it has the same base. So I'm going to make it to the 1/4 power. My bases are the same. So I end up with x equals 1/4. Now, number 20, don't just assume that as soon as you see the word log, this is in log form. This is actually in exponential form, and I'm going to be turning it into log form. So let me rewrite it. So this is the base. Up here is the exponent, and it equals the answer. So right now, this is B, this is E, this is A. It's in exponential form. So let's put it into log. So what we're going to do is log base 3 x equals this exponent. I just spelled out bay here. Now we're going to use that last property that we saw, that when you see exactly the same log base on both sides, you can cancel it, and you're left with your answer of x equals 8. Now, one other little trick that you can use whenever you have an exponential form, so let me rewrite the problem. If the base of the exponent is the same as the base of the log, this will cancel, and then you're left with just 8 equals x, which is the same answer that I got by transforming it into log form. We're going to do 21 the same way. 22. No. That was 20. We're going to do 21 the same way that we did 20. So I can either put it into log form, or I could just cancel out that base 2 raised to the log base 2. So let me move the x to this side. So now I'm going to do, this is the base, the exponent, the answer, it's in exponential form. I'm moving it to log form. So log base 2 of x equals log base 2 of 9. The log base 2's are the same, so x equals 9. The other way, remember, is to take, and if your base of your exponent is the same as the base of the log, these cancel, and you're left with 9 equals x, which is the same thing I got when I transformed it into logarithmic form. (22). It's in log form. Let's go to exponential. X to the negative 2 power equals 25. So here, I'm not solving for an exponent, so I'm not going to try to do a change of base. What I'm going to try to do is figure out what x is. And at first glance, you may think, oh, it's going to be 5. But if you think about it, if you put in 5 to the negative 2 power, this becomes 1 over 25. So 5 doesn't work. But if we were to put in 1/5, that will work. Because when you have a fraction raised to a negative power, you flip it to the reciprocal, make the power positive, and now square it, which is what I tried to equal. So x here equals 1/5. For this one, you would guess and test, and just try to figure out what form of 5 it's going to be. Then 23, it's in log form. 4 to the 3rd power equals x. All I need to do is figure out 4 to the 3rd power, and that gives me what x equals. And then the last one, we've got a radical, so we're going to change it to a fraction. Again, if it helps you to move the equals x to this side, BAE, so 4 to the x power equals the cube root of 16. I'm going to change 16 to the 1/3 power. And then I'm going to change 16 into 4 squared. My bases are now the same. Get rid of the 4's. Multiply this power to the power, and then I'm done. So x equals 2/3. So again, if you can't solve something when it's given to you in logarithmic form, move it to exponential. If you can't solve it in exponential, try transforming it into log, and then find the value of your variable. So for this homework, we're not using a calculator. We're doing everything without. The quiz next Friday is non-calculator. You'll have to do everything showing all this work without a calculator. So you have a 5.2a web assigned homework that's due on Monday. And again, practice with your calculator. You have until the beginning of February before you're actually going to be, tested on how to use it. So make sure that you're practicing and learning the sequence to push the buttons. So that's it. We will continue with these notes on Monday and learn how to graph.